For decades, our collective gaze has been fixed on the distant, rusty allure of Mars. We dream of terraforming its red deserts, of walking under its thin pink sky, and of finally becoming a multiplanetary species. It is a grand, romantic vision, one that has fueled science fiction and scientific endeavor in equal measure. But while Mars has held our imagination captive, a quieter, more urgent race has begun much closer to home. The new gold rush isn't for a distant world, it's for our nearest celestial neighbor. The silent grey expanse of the moon is now at the very center of a new scramble for resources, power, and the future of humanity itself. The destination is familiar, but the mission is entirely new. This pivot back to the moon is born of necessity and staggering opportunity. The surface, bombarded by the solar wind, holds elements rare on Earth, but vital for our future. This isn't about planting flags and leaving footprints anymore. It's about a permanent foothold, building outposts and extracting materials to solve Earth's profound challenges. Imagine a source of energy so clean and powerful it could meet the entire world's needs for centuries without producing harmful radioactive waste. This isn't a fantasy, it's the promise of fusion powered by a very special substance called helium-3. On Earth, helium-3 is astonishingly rare. You could barely fill a suitcase with all the helium-3 that exists naturally here, but the moon is drenched in it. For billions of years, the solar wind has blasted particles outward, and the moon, lacking atmosphere and a strong magnetic field, took the full hit. Vast quantities of helium-3 are embedded in the top few meters of lunar soil. Helium-3 could fuel next-generation nuclear fusion reactors. Fusion merges light atoms and avoids the high-energy neutrons that make nuclear waste so problematic. It's clean nuclear power, reliable baseload for cities and industry. We still must perfect reactors, mine trace concentrations, and bring the fuel home. While helium-3 grabs headlines, the moon's soil holds another treasure, rare earth elements. A group of 17 metallic elements, neodymium, yttrium, scandium, essential to the technology we rely on every day. Neodymium drives powerful, lightweight motors in electric vehicles, wind turbines, smartphones, and much more. On Earth, extraction is messy and politically fragile. Asteroid impacts seeded minerals. Crater rims may hold higher concentrations, platinum, palladium, rhodium, building blocks of high-tech civilization. Mining in vacuum could be cleaner, powered by solar, leaving rearranged dust. Water ice turns the moon into a fueling station. Air, water, and rocket propellant on site. The drive to mine the moon blends economics, strategy, and the unquenchable human spirit of exploration. The numbers are staggering. Demand for rare earths will surge with clean energy. For companies, the moon is a frontier for profit, with legendary firsts. For nations, it's technology and energy independence, national security. Rely on rivals for critical components, and you are vulnerable. Lunar mining secures supply for generations, enabling everything from defense to renewables. The moon is our celestial doorstep and training ground for Mars. We learn to build, extract, and operate in low gravity safely. A base enables astronomy, planetary science, and fundamental physics in pristine conditions. It is the stepping stone to a spacefaring species. Ultimately, we must learn not just to reach, but to stay, live, and help Earth from there. The 21st century race to the moon is not a two-horse race like the USA-USSR era. Today, the field includes established nations, ambitious newcomers, and bold private players. The United States leads with Artemis, a sustainable return, aiming to land the first woman and first person of color and build an Artemis base camp. China has emerged as a formidable competitor, with historic Chang'e successes, including the Farside landing. Plans include sample returns and an international lunar research station near the South Pole with partners including Russia and others. A methodical, well-funded path toward robotic and then human outposts using local resources. The private sector now drives capability. SpaceX's Starship is central to Artemis landings. Massive payloads and rapid reusability could slash lunar access costs. Blue Origin fields New Glenn and the Blue Moon lander for NASA and future clients. Specialized startups are tackling rovers, mining robots, and lunar communications. A vibrant ecosystem is accelerating the timeline to viable lunar industry. Successful lunar mining would be more than a technological triumph. It would rebalance power on Earth. For a century, oil and gas shaped politics and fortunes, fueled conflicts and concentrated influence. Clean fusion, powered by lunar helium-3, would shatter that paradigm. Energy superpowers would be those with advanced spacefaring capability and those who diversify rare Earth supply beyond today's choke points. Mine on the Moon, return to Earth, achieve independence and leverage, influence EVs, turbines, electronics, even defense systems. Guaranteeing stable, ethical supply becomes a powerful diplomatic tool. For the first time, private corporations could wield nation-scale influence, master the lunar supply chain, become the most valuable company in history. But law will be tested. Celestial bodies aren't for national appropriation. Control of resources, transport lanes, and icy poles becomes strategic high ground. This is a race for resources, and to define the rules of a multi-planet future. As we stand on the precipice of a new lunar era, the possibilities seem boundless. Mining the Moon promises solutions in the sky to problems on Earth, from energy to materials. A future powered by clean fusion, ending reliance on fossil fuels and healing our climate. But the engineering hurdles are immense. We have yet to build a fully operational fusion reactor. We must mine, process, and transport lunar regolith economically. Costs will be astronomical. How do we justify them amid urgent needs at home? And how do we manage risks in a hostile environment? Who owns the Moon? Treaties forbid national claims. What about corporate rights? Can we prevent conflict and write fair space law for commerce and claims? Will we treat lunar resources as the common heritage, or the spoils of a race? The choices we make this decade will echo for centuries. The future isn't just written in the stars, it's ours to write, here on Earth and there among the craters.